we thought of the acronym before the name, and the original strategic was actually Swedish, and that's reflected in some of the content of this database. So first I wanted to just say a little bit about something that inevitably pops up in these kind of discussions, and the difference between what are archives and research databases. And there's a lot of sort of top-down incentives to put things in archives to make them findable and reusable. But if you want to do large-scale synthesis work, as the last projects that were shown do, that is of limited use, or it makes it extremely difficult. And one example of doing this is the difference between picking out one book from a library at a time or searching through multiple books. And this is something of different types of logic, and this can be from when you're designing the database to when you're working with the databases as well. And in the long run, we have to integrate these different points of view and different ways of working with things. So SEAD really comes from this point of view on the right. It's more orientated towards integrating data, and the archiving aspects of it have really become more of a recent addition. I'll skip over this. It's designed to work as the sort of central hub of any kind of archaeological or paleo-environmental research process, just as many of the systems we're hearing about are. And essential to that, of course, is storing metadata and data from every aspect of the analysis or research process in the database, and that is done with variable quality and reliability. We're part of a larger network of data providers on the left. The ones in brackets are planned data providers that we're waiting to hear about funding on. And to the right is a sort of broader network of interaction with data partners. So some of these we're working on connecting data feeds to, or data exchange, and some of them are more on the sort of project administrative coordination level. I'll mention a couple of these in more detail later. If you go into SEAD, browser.seed.se, I think it starts up on this page at the moment. We keep changing the way in. You have a series of display panels on the right where you can get basic summary information about what has been filtered up, you could say, on the left. So you can click on the filters button and it will give you different things to search through. So time periods will be an obvious one. I say 38,000 samples, but a lot of these are things like soil survey samples. So it's a multi-proxy database. It's mainly based in Sweden, but the Bugs CEP database that you heard about before is also a major part of it, and in fact is the larger amount of data. Most of the Swedish data comes from commercial archaeology, which is maybe useful to know, and that's very variable in its quality. The insect side of things, which is what I'm most interested in, we have about just over 8,000 samples in there, and I know Jesse is trying to make some use out of that in their project. Things that are coming soon. One of the biggest problems with any form of multi-proxy or large-scale data synthesis is dealing with the age problems, and I think in SEAD we have about, as you would expect, 40-odd different dating methods that need to be compiled into something useful. And so what we've been working on is a single minimum maximum age range for every sample in the database, and that's a massive amount of work that one of our postdocs has been doing, and that should be ready soon. The other thing is linking our fossil taxonomy to contemporary biology taxonomy. And for the beetles, about 75% of species and genera or taxon can be linked reasonably easily through synonyms to GBIF, but that leaves about 2,500 taxa which have fossil taxa that are not in GBIF. So we've been discussing how to solve that, and these are basically going to be created as new fossil taxa. rapid bit of history. So Joe's question earlier about access databases and accessibility. For a long time, I've thought that Access is not a open and accessible format, but I'm changing my mind. So SEAD originated in the original books, you could say, which was a DBase 3 database, which became the Access format. We can still read those files. We can open them with Excel, QGIS, Postgres, and we can get at the relational structure and do really powerful research. We can't do that with any of the ASCII files that were put in repositories at that time. So a little plug for Microsoft there, even though it pains me to do it, but it's more sustainable format than you may think. Lots of different databases and projects interfacing in this, and these are all the different sources of funding we've had over the decades. I calculated this is about 3 million euros in total has gone into this, and I would have hoped we'd come much further, to be honest. We work on a principle of virtual constituent databases. We borrowed this idea from Neotoma, who's one of our partners in this. So a database can have its own identity within the database and can have its own portal. And we're working on a dendrochronology portal with people in Lund, Stockholm, and Gothenburg. Another thing that is missing from our filters is a geochronology filter, which is coming soon. It's going to be a time bar on the bottom, things like that. I said at the beginning, this is from a research-orientated way of designing things. So here's an example of what I mean by that. I've used the filters to just get the grain weevils, Cytophilus granarius. I've asked what ecological classifications the grain beetle has, obviously stored grain pest, but also an indication of human activity. Then got a list of which sites, and just for fun, put up a list of countries. All the dots on the map show the sites, and then you can delve into the data to see the earliest record is down here outside of Israel, and then it sort of spreads off. You can look at Eva Panagiotopoulou's publications to see that explained and published. On the importance of small records, so Pap Castle here has a single record of a grain weevil. It's very, very small data, but it's extremely important if you're building large-scale models of single species rather than large-scale syntheses of the interpretation of these things. So yes, law of diminishing returns, but every small bit of data could be important. Then what we can do is flip this around. So here we've seen what the environmental indications of a single species is. Then we flip the filters around and see what other species give us the same environmental indications. And if you watch the map, we get a few more sites. So here we're looking at stored grain rather than the implications of a single grain pest. If you click on a site, it will bring you to a landing page. These are permanent URIs. We're working on DOIs, just some administrative API issues there. Each of the data sets becomes expandable underneath. You can, yes. Disclaimer there, there's a lot of mess in the database. There are publications that are in the wrong fields. There's missing data, descriptors that are missing data. And this is one of, author. A lot of work to do there. And that's something that unfortunately takes more time than funders tend to appreciate. Click on a particular proxy type or data area, and it will give you a visualization of the taxa, in this case, found at that site, and you can just explore that. You can download the individual data sets, not in the best format at the moment, but we're working on that. Another thing, to answer an earlier question that popped up, we have a taxa called no data. So we list all the samples that did not deliver anything. We haven't done that for the pollen, and it's only certain things that have gone into our database. So that's a big issue. APIs, if you want to do large-scale synthesis, then of course you don't want to use the web interface. You want to type in, say, a web string in your R package or whatever, and it will pump that data out into a standardized format. Currently, according to the EarthLife Consortium API schema, but we have other APIs for feeding to different data systems, including the Swedish Biodiversity Data Infrastructure and some other projects like DataArc. That just shows you one database, many ways of communicating with many other databases, and that is really the way to go forward with federated data. That's what it looks around in the background. Old school relational database, lots of mess, but it allows you to make very, very powerful queries. This may have been in the same Pages magazine that was mentioned earlier, but we have been working with lots of other projects to try and link data on interpretation rather than data. So semantic networking, which is an interesting way of linking something like a saga map to, or a Icelandic saga to a insect record. What can you do with it? Well, you can ask it for all of the insect records from the Ice Age for the UK, and then you can do climate reconstructions based on that. You can pull up environmental reconstructions based on the classification of species. Here we're comparing Roman and Bronze Age wells or waterholes to look for anomalies and similarities. And coming very soon, we hope, this is under review, you can look at the fossil record of threatened species and see whether that can help you understand why they are threatened species in the present. And this is one of our postdocs, Francesca Pilotto, who's the lead author on it. What I showed you there was the public version of it. We have a not quite working version in the background that is much more powerful and allows you to do a lot more of different filtering queries, you could say. Has things that we wanted to build in from the beginning, like aggregated data export. So if you want to do a set of queries, really you want to get that out through an API feed or as a massive CSV file or a set of CSV files and things like that. At the moment, we don't have that functionality. You get, just like an archive, a single data set at a time. And that's not really ideal. This is a prototype working on a dendrochronology database, as I said, with Lund, and we just got a large grant to work on that over the next 4 years. So that's really fun. Is it fair? No, it's not fair. We were part of a Nordic fair data evaluation 2 years ago, 1.5 years ago, and we scored, as you can see on the left, 12.5% for findable, 40% for accessible, nothing for interoperable or reusable. Terrible, but also common with the vast majority of the 172 repositories that were evaluated in the Nordic region. We've done some improvements based on this last year, and we managed to at least be acknowledged as being partly interoperable. We failed abysmally at reusable because of one simple thing. We do not have a link to a license in our landing pages or data feeds. So some of these things are quite easily fixed. And are they particularly useful? Maybe for a machine, maybe in the big picture. For the most scientists' purposes, we don't care about licenses. It's all, I write on the website, it's open data. But of course, that's not a sustainable approach. I think I'll finish there, and thank you for listening, and thank you for all the people who have contributed to these databases and to the funders who hopefully will keep giving us money to make this better. Okay.